A motorist makes 3 driving errors, each independently resulting in an accident with probability 0.25. Each accident results in a loss that is exponential with mean 0.8. Losses are independent and independent of the number of accidents. Insurer reimburses 70% of each loss due to an accident. Calculate the variance of the total unreimbursed loss the motorist experiences due to accidents resulting from these errors. Now, there are 3 driving errors, but an error doesn't necessarily cause an accident. After an error, the probability of having an accident is 0.25. So we don't know how many accidents will be caused by these 3 errors. So we let x to be the number of accidents. So then x is binomial because you are doing 3 errors, and each error will either result in an accident or not an accident, and the result of the probability of accident is 0.25. So therefore the mean or the expected value of x is that of the binomial, which is np, so 3 times 0.25, and the variance of a binomial variable is np times 1 minus p, so that ends up being 0.5625. So let L be the loss of each accident, and we are given that each loss is exponentially distributed with mean 0.8. So that means expected value of L is 0.8. And for exponential, we know that variance is the square of the mean. So the variance of L will be 0.8 squared. Now we are interested in the unreimbursed loss because calculate the variance of the total unreimbursed loss. So first we concentrate on each reimbursed loss, which means the reimbursed loss due to each accident, and then we'll add them up to get the total unreimbursed loss. So 70% of the loss is reimbursed, so which means 30% is unreimbursed. So if y is the unreimbursed loss due to each accident, then y is 30% of L, or 0.3 L, and the expected value of y would be 0.3 times expected value of L, because if you have a times x, where a is a constant, then the expected value of ax is a times expected value of x. So it'd be 0.3 times expected value of L, 0.3 times 0.8. And similarly, the variance of ax is equal to a square variance of x. So variance of y will be 0.3 squared variance of L, and 0.3 squared times 0.64. So that's 0.0576. So that's the expected value and variance of each unreimbursed loss. So let T be the total unreimbursed loss. Y is one unreimbursed loss, and T is the total of unreimbursed losses due to accidents. Okay, so Y is the unreimbursed loss by one accident. So then, since T is the total of X accidents, so expected value of T given X accidents would be X times expected value of, so T is the total loss. So the expected value of the total loss given X accidents will be the X accidents times the expected value of loss due to each accident. So that's just like that central limit theorem. Obviously, we're not here saying that the resulting distribution of the sum will be normal, but this result that the mean is equal to the number of variables that are involved times the expected value of each variable, that result still holds, and the same for the variance. So there are x accidents, and the mean of each loss is E of y. So the mean of the total loss will be x times E of y, and E of y is 0.24, so 0.24x. Similarly, variance of total loss will be x times total loss by, total unreimbursed loss. It's the same over here. T is the total unreimbursed loss. The total unreimbursed loss for x accidents will be the x times the variance of each unreimbursed loss. This should be y. And that's 0.0576x, because variance of y is 0.0576. Now we are ready to use our main formula, that variance of t. That's what we needed. We needed the variance of the total unreimbursed losses, and we are calling that as t. So variance of t is expected value of variance t given x plus variance of expected value of t given x. And then we substitute the variance t given x, which is 0.0576x. And here we substitute the expected value of t given x, which is 0.24x. And the same rule, expected value of ax will be a times expected value of x. So the 0.0576 comes out. And the variance of ax is a squared times variance of x. So 0.25 squared times variance of x. And E of x is 0.75. Remember, that's what we said in the very beginning. E of x was 0.75 and variance of x was 0.5625. So substitute those for the ex and the variance x, and we end up with 0.0756, which is choice B.